Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to factor polynomials by grouping. This standard is covered in Algebra 1 and Algebra 2 courses. Don't forget there are 8 practice problems at the end of this presentation that we'll like you to try out to demonstrate mastery of what we've covered in this tutorial. If you'd like to gain access to the entire playlist and other valuable resources, do take a look at the link in the description below, or you can just visit our website at mathgotserved.com. Alrighty, the instructions for the examples that we're working on are as follows. We are to factor completely by grouping. Alright, so we're going to be using the grouping method to factor. So for question number 1, let's say we have the polynomial expression 3x squared plus 21x plus 2x plus 14. Okay, so let's go ahead and factor that. So when you're factoring by grouping, first thing you want to ask yourself is, are you in a position to factor by grouping, or is there something else that has to be done first? If you want to factor by grouping, you need an even number of terms, okay? So you can split it down the center. So if you take a look at what we have here, we have 1, 2, 3, 4, 4 terms. This is great because we can split it down the center and then factor by grouping. Okay, so when you're splitting, you split it in front of the sign, right? To the left of the sign, so you split it down the center. Alright, so now after splitting down the center, we're going to proceed to break down the polynomial to the left and to the right of our split. Okay, the goal of that move is to enable us to factor out the GCF from the left and the right side of the split. Okay, so let's go ahead and split the left side. This 2 terms right here of our split. If you break down 3x squared, you're going to have 3 times x times x. Okay, plus if you break down 21 into prime factors, it's going to be 3 times 7 times x. Okay, and then you always bring down the middle sign. In this case, we're bringing down the positive sign. And then we're going to break down 2x and 14. So since 2 has a common factor with 14, we just break it down like this, 2 times x. And then if we break down 14, we have 2 times 7. Now let's take a look at the left side of our partition and see if there's a greatest common factor that we can factor out. And the answer is yes, we can factor out. We have a 3 and a 3. And then we have an x and an x. So on the left side of our split, the GCF is 3x. So we're going to factor out the GCF, 3x. Now when you factor it out, you divide it out. So this 3 is factored and divided out. You're left with 1. And then this x is factored and divided out. You're left with 1. So after you factor out 3x, you're going to be left with x. This x right here plus 7. Okay? All right. And then we'll bring down the middle sign again. Remember, you always bring down the middle sign. Now, something to keep in mind is if you have a plus, then you have no complications, okay? But whenever you're bringing down a negative, you have to be careful because whenever you factor out a negative, signs change. All right, so let's see what we can factor out here. 2 and 2 are common. So the GCF of the right side of the split is 2. So we factor out the 2. Actually, it's technically positive 2. And when we factor it out, we divide it out. Okay, so 2 is gone and 2 is gone. And we're left with the quantity x plus 7. Now at this point in time, you freeze and check and ask yourself, how are we looking? Now, if the quantities in the parentheses are identical, then everything is great. We're looking fantastic. But if the quantities are different, then perhaps a mistake was made and we have to go back to check our work. In this particular case, we can see that the quantities are identical, which is great. So we're going to go ahead and factor them out, okay? So this quantity, x plus 7 and x plus 7 are common, so we're going to factor it. So let's put a squiggly here and a squiggly here. those two common quantities will be factored out. So we have x plus 7, the quantity x plus 7. Now when you factor it out, you divide it out. 1 and 1. Okay? Now you're going to be left with 3x and positive 2. What do you do with those two terms? You group them together in their own nice little parentheses. 3x plus 2. And ladies and gentlemen, this is the factored state of question number 1. Okay, let's take a look at another example, problem 2. Let's say we have the expression n squared plus 4n minus 4n minus 16, and we want to factor completely by grouping. Okay, the difference here is that in the middle we have a minus, so you want to proceed with caution anytime you have a minus as the sign in the middle. Okay, so what we're going to do first is partition or split the expression. We have 4 terms, which is excellent, so we can split it evenly down the center. All right, so after the split, we're going to proceed to break down each term. Okay, so if we break down n, we have n times n. If you break down 4, that's 2 times 2, break it down into factors, times n. Now we have a minus. Okay, so we want to watch out for that minus sign, bring down the minus, and then if you break down 4, you have 2 times 2 times n. And then if you break down 6, oh sorry, this is supposed to be 16. If you break down 16, that's 2 times 2, that's 4 times 2, that's 8 times 2, that's 16. Okay, so you just break down 16 using your factor tree. All right, now let's take a look at the left side of our partition. What's the GCF there? If you notice, we have n and n common on the left side of our partition, so n and n are common. So that's the GCF of the left side is n. So we factor out n and we divide it out. Okay, so n is factored out and then you divide it out, because when you factor out a term, it's as though you're dividing the original term by that factor that you factored out. Okay, and then we're left with n plus 2 times 2 is 4. Okay, on the left side here, like I indicated, when you have a minus, you want to proceed with caution. Okay, so in this particular case, we're going to be factoring out minus, because the minuses are common, and the GCF. So we have 2 and a 2. We have another 2 and another 2. So we're going to be factoring out negative 2 times 2, which is 4. So we're going to factor out negative 4. Okay. All right, and then I will factor it out. Well, let's write it out in its decomposed form first so that you see exactly what's going on. So we're taking out a 2 times a 2. Okay. Now this is the deal right here. Since we're taking out a negative 2, what's going to happen is that these 2's will get divided out, this 2 and that 2, and then this 2 and then that 2. And guess what? The minus is, whenever you take out minuses, the signs flip. So this becomes a plus and that becomes a plus, because when you factor out a minus from any sign, the sign becomes the opposite of what it was before. Okay? So now guess what? We're going to be left with positive n plus 2 times 2. Okay, let's simplify that a little bit. So we have n times n plus 4 minus 2 times 2 is 4 times n plus 2 times 2 is 4. Now let's ask ourselves, how are we looking? We're looking fantastic here because the quantities in the parentheses are identical. So the quantities n plus 4 and n plus 4 are common, so we're going to factor them out. We have the quantity n plus 4. So we'll factor it out and divide it out, left with 1. Divide that out, left with 1. And then the terms on the outside, n minus 4, will be grouped together in their own little parentheses. And ladies and gentlemen, that's the answer to question number 2. Alrighty, let's take a look at another example. Question number 3. Now let's say we're to factor the quantity 10z to the second power minus 15z plus 4z minus 6. Okay, so we have 4 terms here. We're going to break it down the center, and then we're going to factor by grouping, okay? So we'll break it down this. Let's do this. Let me rewrite it again. So we have 10z squared minus 15z plus 4z minus 6. All right, so we split it down the center with our partition in front of the sign. Okay, now let's, after the split, we're now going to break down each term so we can pull out the GCFs on the left and right sides of our partition, okay? If you break down 10 is going to be 2 times 5, and then times z, since z is raised to the second power, minus if you break down 15, that's 3 times 5 times z. Bring down the plus. Well, this is nice. We have a positive sign here, so nothing strange happens with the signs of the terms to the right of our partition. Break down 4. 4 is 2 times z. And then when you break down 6, you have 2 times 3. Okay. Now we're going to proceed to extract the common factors. To the left side of our partition, we have 5 in common. And then we also have a z. Okay, so what we're going to do now is we're going to factor out that GCF and divide it out. Okay, so we're going to factor out 5z and then divide it out. So that's 1. And then divide out the z that we factored out. And we are left with 2 times z, which is 2z minus 3. Okay. Now we're going to bring down the positive sign. To the right side of our partition, what's the GCF? We'll have a 2 and a 2 common, so the GCF on the right side is 2. So pull that out. We have 2. Factor it out, and then divide it out. So 2 goes here 1, 2 goes here 1. And now we're left with 2z minus 3. Okay? So how are we looking so far? This is where you freeze and check. We're looking great here, ladies and gentlemen, because the quantities in the parentheses 2z minus 3 are identical, which is fantastic. Okay, so now what we're going to do next is we're going to factor out the identical quantities, 2z minus 3, put a squiggly beneath it. So we're going to factor it out, okay? So factor it out. When you factor it out, you divide it out. 1, 1. And then the terms on the outside, 5z plus 2. What do we do with those? We group them together in their own nice little parentheses. And ladies and gentlemen, that's the factored state of question number 3. All right, let's take a look at one more example, and then we'll give you some practice problems to try out. Let's look at number 4. So for problem 4, let's say we're to factor 6a squared minus 2ab minus 9ab plus 3b squared. Okay, so we're to factor this by grouping. All right, so first things first is to split our polynomial down the center. We can do a split here because we have 4 terms and that's even. So we can have an even split, 2 terms to the left and 2 terms to the right. All right, now we're going to break down each term, okay? So if you look at the first term, if you break it down, that's going to be 2 times 3 times a minus 2 times a times b. And oh dear, we have a minus here, so we want to be careful with that. If you break down 9, you have 3 times a times b. And if you break down 3b, b squared is going to be 3 times b times b. Okay? All right, so now let's pull out our GCFs. On the left side, we have a 2 and a 2, and then an A and an A. So if we factor out the GCF there, we will have 2A, factor it out, and then divide it out. Okay, 2 and 2, and then an A and an A. So we're left with 3A minus B on the left side of our partition. Now we're going to be bringing down the minus down here, so when we take out a minus, the signs are going to flip. So what we're going to be pulling out on the right side, we're going to be pulling out 3 and a 3, a B and the B, and then that minus sign also we're going to be pulling out. So if we pull out the GCF negative 3B, this is what's going to happen. The 3's get divided out. 3 goes here 1, 3 goes here 1. The B gets divided out, and then the signs flip. This minus becomes a plus, and this plus becomes a minus. Alrighty? So we're going to have left 3A minus B. Okay, so remember, anytime you factor out a minus, the sign of the term that you factor out that minus from will flip to the opposite. Alright, so let's go ahead and see how we're looking right now. We're looking fantastic because the quantities in the parentheses are identical, so let's identify them. 3A minus B and 3A minus B are common, so we factor that out. Quantity 3A minus B. And then what's left? Oh wait, okay, so when we factor it out, we gotta divide it out because it's gone. And what's left is 2A minus 3B. And we group that together in its own nice little parentheses. There goes the answer to question number 4. Okay, we need to do one more problem. There's another problem that we have to do before we do the practice problems. So number 5. Sorry about that. We're going to do one more. So for number 5, let's say we were to factor 6x squared plus 15x minus 2x minus 5. Okay, so let's go ahead and see how we can factor this by grouping. There's a special situation we're going to be dealing with here. That's why we're doing this additional example, so you can know how to attack problems of this nature. Alright, so we're going to split it down the center, and then we're going to break it down. Alright, let's do it. So if you break this down, you have 3 times 2 times x times x. If you break down 15, you have 3 times 5 times x. And then bring down the minus. Now take a look at this. 2 and a 5, they have nothing in common. Okay, so when you have a scenario like this, when you have nothing in common, when you're breaking it down, you're going to have to factor out a 1. 1 times 2 times x, and then you factor 1 from 5. Well, what does this show us? It shows us that you can always factor out a 1. If nothing comes out, you can always pull out a 1 from every term. Okay, 1 is a factor of everything. Okay, so now let's pull out the GCF. On the left side, we have a 3 and a 3, and then an x and an x. So we're going to factor it out, 3x. Okay, so when it's factored out, we divide it out. 3 and 3 are out, and then x and x are divided out. So we're going to be left with quantity 2x plus 5 in the parentheses. Okay, so now we're bringing down a negative sign here, so we're going to be careful with that. I would take out a minus, and the GCF, what's the GCF? We have nothing is common, so we just pull out a 1 and a 1. Okay, so remember, anytime you can factor out anything, you can always factor out a 1. So since we're factoring out minus 1, what's going to happen is that this 1 is divided out, still a 1 and a 1, but the signs flip. This becomes a plus and that becomes a plus, because anytime you factor out a negative, you have a sign flip. So you're left with 2x plus 5. All right, how are we looking? We're looking great because the quantities in the parentheses are identical. Okay, so let's go ahead and factor that out. 2x plus 5, factor it out and then divide it out. Okay, so that's 1. That's 1. And then what's left on the outside, you group it together into this nice little parenthesis. And ladies and gentlemen, that is the factored state of question number 5. Alrighty, ladies and gentlemen, it's now time for you to apply what we covered. So we have 8 practice problems that we would like you to try out. So what we'd like you to do at this time is pause this video presentation and factor out the following problems. And when you're done, click on the playback button in order to see what the answers are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. So let's take a look at what the answers are. So for problem number 1, we have 2a plus 3, 2a plus 3b times 3a minus b. And then for problem number 2, the answer is 3x plus 1 times the quantity 2x plus 5. Number 3, we have 4x plus 3. 4x minus 1 times the quantity 5x plus 3. For problem number 4, we have the quantity 8x minus 9 times the quantity 3x plus 2. All right, and then over here, there's 3x minus 2, actually. All right, for number 5, we have a quantity x plus a times y plus b. For number 6, we have the quantity n minus 3m times the quantity n plus 2. For number 7, we have the quantity 7h plus 1 times the quantity h minus 3. For number 8, we have the quantity x minus y times the quantity x plus 2. Alrighty, so there goes the answer to question numbers 1 to 8. So how well did you do with these practice problems? Well, let us know in the comment section below. If you have any questions concerning any of these problems or any factoring by grouping question in general, just specify your questions in the comment section below and we'll be more than glad to respond. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of factorization of polynomials, do give us a like. Your positive feedback is very valuable to us. If you have any questions or comments, just post it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to future uploads. We upload videos to our page on a daily basis. If you like access to more support resources, you can visit our website at mathgotserved.com or just take a look at the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.